Good day. My topic for today is the current divider formula. So, the application of the current divider formula is that if we have a two-port network with two branches, two-port in line na yan, with two branches, we can solve the branching currents I sub 1 and I sub 2. For branching current I sub 1, this is equal to the total current IT multiplied with the resistor on the opposite branch kasi I1 ito, this is the opposite branch of I1 which is R sub 2 divided by the sum of the two resistors connected in parallel. Same is true with I sub 2. The current I sub 2 states that this is equal to the total current multiplied with the resistance on the opposite branch divided by the sum of the two connecting resistors or the parallel resistors. Yan lang yung application ni current divider formula. Solving for the branching currents. Again, for I sub 1, I sub 1 is equal to the total current multiplied with the resistance on the opposite branch divided by the sum of the two branching resistors. For I sub 2, it is equal to the total current multiplied with the resistance on the opposite branch divided by the sum of the two parallel resistors. Okay, i-part na natin yung discussion on the current divider formula because we will be using this as an alternative solution for the current on the other network. Okay, the Thevinin'S theorem states that the application of the Thevinin'S theorem is that when a network of fixed resistances and constant sources of EMF of any degree of complexity, it is so disposed that only two terminals is accessible. Dalawang terminals lang yung accessible. So, the current through a load resistor that is connected to the two terminal may be determined by two simple tests. Okay, the current on the load resistor can be determined without altering yung mga nandyan. Pwede na hindi kukunin yung mga branching currents dito by the following test. One is an open circuit test. That is the Thevinin'S theorem. Later, yung short circuit test can be determined using the Norton's theorem. Now, again, application of Thevinin'S theorem states that any network with two open terminals, terminals A and B can be replaced by a single voltage source in series with a single resistance which is R sub O. So, yung E sub O, sabi niya, ito daw can be replaced with a single voltage which is E sub O measured on the terminal A and B. Later, i-explain ko kung paano siya kukunin yung E sub O in the process of using the open circuit test. And a single resistance, sabi niya, with a single resistance which is equal to R sub O. Where E sub O is again an open circuit voltage with R sub O is the looking back resistance. So, again, the methods is using the Thevinin'S theorem or the open circuit test, remove first the load. Ang load natin dito is R sub L. So, i-disconnect natin yung terminal A and B from the main circuit. So, this is now the diagram. A and B now is open. Terminal A, B is open. So, we can now measure the voltage of E sub O. Ang tawag doon sa kanya is the open circuit voltage. So, measuring, it means we can also obtain by solving the currents. Pag actual, i-open natin siya, i-measure lang natin yung voltage. Pero pag ganitong schematic diagram, we have to solve for the open circuit voltage using other theorems. Then, R sub O, looking for the looking back resistance, this is the same as the equivalent or R equivalent or resistance equivalent. Kaya lang, si R sub O is measured at the receiving end dito. Ang R equivalent, andito siya ni-measure. Yung R sub O dito sa receiving end. So, requirement for solving for R sub O is remove all the sources of EMF. Then short circuit each terminal. Again, solving for E sub O muna is open the RL and remove the load. Then look for the open circuit voltage using any other method. Solving for the looking back resistance is pag mayroong source of EMF, remove that EMF, then short circuit its terminal and solve the looking back resistance. So, after identifying or measuring, identifying the open circuit voltage and the looking back resistance, this is now the Thevinin'S equivalent circuit. Sabi niya kanina, can be simplified into a single source of EMF, which is the open circuit voltage and the looking back resistance, which is in series with RL. So, ibabalik natin yung RO at saka R sub L, which is in series. R sub O is in series with R sub L. So, this is now finally our IL, or the current of the load. Same current obtained from this network or from this circuit. So, ibig sabihin, na-shorten yung method of solving I sub L by using this circuit, simple circuit. So, ulitin ko, itong circuit na ito can be replaced with the Thevinin'S equivalent circuit. Yung I sub L na ma-obtain dito is the same IL obtained from this complicated network. So, it is a simple Ohm's law. I sub L is equal to EO, or the open circuit voltage, divided by RO plus R sub L. Okay? So, ito na ngayon yung kanyang equivalent. Kalimutan na natin yan. Pag nakuha natin si E sub O, RO, ibalik natin si RL, and this is now the equivalent circuit. Okay. Given yung the same as our midterm exam, pinasolve ko yung total power, total current, total power, at saka yung current at the load resistor. Nobody got the correct answer for R sub L, I sub L. Kasi nga, ito, yung I sub L, dinivide nyo doon, which is not, or I sub L is equal to voltage at saka yung RL, so hindi yun. So, mali lahat yung solution nyo doon sa I sub L. So, ipakita ko paano using the Thevinin'S theorem. So, required power delivered at the RL. Ito, power dyan. So, of course, we need to solve for the I sub L. So, ito na ngayon yung circuit. Sabi niya, open the terminal. Remove the load first, then open the terminal A and B. Tinanggal ko na yung RL dyan. Itong RL nito, ito na, naka-open na siya. And solve for E sub O. So, solving for E sub O, we need to solve for the current at 24. Ito dito, current dito. Since open ito, the current at 6 ohms, yan, current yan at 6 ohms is equal to 0. Open, walang dadaanan yung electron. So, ibig sabihin, walang voltage drop yan kasi ang current is 0. Kung ano yung voltage dito, which is equal to E sub O. So, ang kailangan lang natin na voltage, yung voltage at 24 ohms. So, kung voltage ang kailangan natin yan, kailangan natin si current niya, kung ilan yung current. Solving for A sub O, sinod ko muna yung, kukunin ko muna yung, ang first objective ko is to look for the equivalent resistance ito. Itong 8, 12, 24 at saka 24, hindi na kasali yung 6. So, bago makuha si R equivalent, sinimplify ko si 12 at saka 24, which is in series. So, 12 plus 24 is 36. Then, R sub B, yun yung combination ng RA at saka 24. So, si R sub A is in parallel with 24. Therefore, RA is 36, 36 times 24, divided by 36 plus 24, so it is 14.4 ohms. So, we can solve for the R equivalent. So, R equivalent is equal to simply 8 plus yung equivalent nito, which is equal to R sub B, which is 14.4, so 22.4 ohms ang R equivalent. So, after solving for the R equivalent, pwede natin isolve si total current. Yung total current ito, hindi yung total current yan. Magkaiba yan. O total current dito magkaiba. Total current dito kasi na-remove yung load. So, I total is simply equal to the increased voltage divided by the R equivalent. Ito, yan. Hindi yung doon ang R equivalent nito. So, again, I total is equal to 53.57 amperes. So, solving for the branching current, ito lang kailangan ko si I2. Sabi ko nga kanina, para ma-solve ko yung voltage yan, kailangan ko yung current dito. So, this is not the use of the current divider formula. Since I sub 2 lang ang kailangan ko, alam ko na si I total dito, we can directly solve for the I sub 2. I sub 2, again, by current divider formula, sabi niya, is equal to, I sub 2 is equal to the total current multiplied with the resistor on the opposite branch divided by the sum of the two resistors. So dito, apply natin siya dito. I sub 2 is equal to the total current times 24 divided by the sum of the two resistors. Connected in parallel ito, kasali sa ito, nakaseries siya. So ang treatment nito is 24 series, nakaparallel sa ito sa 24. So it is equal to 24 plus 12 plus 24. Ito partner siya, kasali siya ito sa package niya. So I total, I2 is equal to 2.143 amperes. Then, again, sabi ko, si E sub O can be solved now using the voltage drop dito. So E sub O is equal to I sub 2, yun, kinuha natin yan, times 24, that is equal to 2.143 times 24. So E sub O is 51.43 volts. Okay. Now, let's continue on solving for the R sub O. So, ito na yung solving for R sub O. Sabi niya, the step or the requirement for solving R sub O is to remove the E and F, ito, source voltage, and short circuit each terminal. So, ito yung, tinanggal ko yung 120 dyan, naka-short circuit yung kanyang terminal. So, this is now our R sub O. Dito, R sub X, nilagay ko yung R sub X is equivalent ng 8 and 24. Since 8 and 24 is in parallel, so it is equal to 8 times 24 divided by 8 plus 24 equal to 6 ohms. Yung R sub X naman is in series with 12. That is R sub Y. So R sub Y is equal to Rx plus 12. Since series sila, we have 6 plus 12, it is equal to 18 ohms. So, pwede nang masolve yung looking back resistance. R sub O is equal to, pag nasolve natin yung R sub Y is in parallel with 24. Ito. So, teka, 18. Okay, R sub Y, which is equal to 18, which is in parallel with 24. So, 18 times 24 divided by 24 plus 18. So, ang combination ng 24 with R sub Y is in series with 6. So, plus 6. So, shortcut. Kung hindi nyo kayang gawin yan, gawin nyo yung mano-mano, yung wrong method. So, this is equal to 16.285 ohms. So, nasolve ko na si E sub O. Meron akong E sub O dito. Nasolve ko na si R sub O. Then, babalik ako doon sa Thevinin'S equivalent circuit. So, ito yung Thevinin'S equivalent circuit niya. I-support ko lang yung mga nasolve. This is our R sub O in series with R sub. Fix na yan. Yan na yung Thevinin'S equivalent circuit niya. Ang E sub O is 51.43 volts. RO is 16.25. Binalik ko na yung tinanggal ko na RL, which is equal to 30. Dito na. So, this is now the I sub L, which is the same value dito sa original na circuit, R sub L. So, to EO divided by RO plus R sub L. Ito, formula. So, E sub O is 51.43 divided by 16.28 plus 30. This is 1.11 amperes. Therefore, pwede ko na isolve si total power. The total power na P total is equal to IL squared R sub L. Right. This is now equal to I squared 1.11 squared times 30 ohms. So, ito na ngayon yung kanyang total power delivered at the PL, RL watts. Okay?